Welcome to Easy BTech, your guide for BTech and beyond. In this video, we'll learn about what is the coefficients for refracted and reflected waveforms when the line terminated the line terminated through a short circuit. Terminated through a short circuit. Okay, we will take the transmission line. Take the transmission line. It is connected to a certain voltage. Here it is short circuited. I'm short circuiting the transmission line. Okay, this is the switch. If closing the switch, the waveform is the surge is flowing through the from sending end to receiving end. It is short circuited. Line is short circuited. What about the resistance? Resistance becomes zero. Already we know the formulas when the line terminated through a resistor. V equals to 2R divided by R plus Z naught. I current waveform is 2 into Z naught by R plus Z naught. Voltage waveform is R minus Z naught by R plus Z naught. Current waveform is minus into R minus Z naught by R plus Z naught. It is the formulas for the line terminated through resistance. Now we will find the coefficients for both the refracted and refracted. When the line terminated through short circuit means resistance becomes zero, R becomes zero. Substitute R equals to zero in this equation, we get the transmitted voltage coefficient becomes zero. Because R equals to zero, it becomes 2 into 0 by 0 plus Z naught becomes 0. Therefore, voltage waveform equation is 0. Transmitted current I equals to 2 into Z naught by 0 plus Z naught. It becomes 2 Z naught by Z naught. Z naught get cancelled. You get 2. Now voltage waveform. Voltage waveform, reflected voltage waveform. 0 minus Z naught by 0 plus Z naught. It becomes minus 1. I double dash minus of 0 minus Z naught by 0 plus Z naught. Okay, Z naught is this impedance. It becomes plus 1. Okay, those are the coefficients for voltage and current waveforms in short circuit is V equals to 0, I equals to 2, V double dash equals to minus 1, I double dash equals to plus 1. We will analyze in the transmission line. The transmission line, this is assume that it is a transmission line. The wave is initiated here. The length of the line is L. At t equals to 0 plus, the surge is initiated here. Therefore, a voltage waveform is initiated. A voltage waveform V is initiated at a t equals to 0 plus. And also, I am representing this. We have to represent like this. A voltage waveform V is initiated. Like that, the current waveform I is also initiated in short circuit line. What happens if it reaches the L? The voltage wave is available and the current wave is available after traveling the L. Okay, means after it reaches the L, it's having V and I. Now, how much waveform is reflected back? We will see at t equal to L plus. What is the reflected coefficient of voltage waveform? The voltage waveform reflected coefficient is minus 1. How much is incident? V is incident. Therefore, minus V is reflected back. Here. I is initiated. How much is reflected back? The reflected current waveform is 1. Okay, therefore this is I, here I is initiated. This is V, minus V is initiated. Now, how much you get here? At T reaches the 2L, back to the line, initial position, the voltage waveform becomes 0, current waveform becomes 2I, I plus I 2I, 2I. Now, how much voltage waveform is initiated here? The now initiated voltage is minus V. How much is reflected at a t equals to 2L? How much is reflected? The reflected coefficient is minus 1. Therefore, minus of minus V, it becomes V. Therefore, V is initiated at 2L plus. V is initiated. If V is initiated, automatically current waveform reflected coefficient is also 1. Therefore, according to the 2I already is there, then again the current waveform is initiated here. What about the waveforms if it reaches the 3L? At t equal to 3L, the voltage in the line is V. The voltage in the line is V. The current in the line is 3V. Sorry, 3I. Now, again reflected back, I am analyzing. Keep in mind, this is the transmission line. At t equal to L, it reaches the L. At t equal to 2L, it is reflected back. Again, it is reflected back. It is 3L. Okay, we are at 3L. Now, how much is reflected back is 3L plus. It is, okay, now it T equals to 3L, 3L plus. Now, how much is reflected back? Okay, what is V is incident, therefore, minus V is initiated because the reflected coefficient is minus 1. That's why minus V is reflected. The incident voltage is I, therefore minus plus I is initiated here. Plus I is initiated. Therefore, it reaches the again sending end. Therefore, T equal to 4L. Then the voltage waveform becomes 0, but the current waveform is 4I. From this diagram, it is clear that the current is like a fault current. If you are short circuited, more amount of current flowing through the transmission line. Okay, but there is no voltage waveform, but current is more if your line is terminated through a short circuit. Thank you for watching.